Okay, good news about this section is it should be a lot of review of what we already know. I did put it in here because there's a lot of vocab in here that we're going to use for the remaining of this chapter and a little bit of the next chapter. So this review will be worth it. The intro states that at the next concert, the groupies invited their manager along. She was more interested in the amount of money being made than the music. She asked the two turtles and a sloth manager how they keep track of the money being made. He had a list of the first 4 hours of the concert. And there they are. Hour 1, 2,500, 2, 1,500, hour 3, 2,000, and hour 4, 3,000. Carly, who was the groupie's manager, suggested organizing the data in a table or a graph. And again, we've used tables and graphs before. We just have to remember how to set them up and what all of this data represents. So we're supposed to create a table and a graph that represents the money made per hour. Well, looking at this, we are comparing hours and we are comparing money. So in our first column here, it depends on the hour as to how much money we have made. So hours, we have 1, 2, 3, and 4. Money, we have 2,500, 1,500, 2,000, and 3,000. Understanding that hour 1 is related to that 2,500, so that's called a relation. Setting them up in tables. Now we have to look at this graph, and a lot of times when you have a blank graph, I like to have the students just take their time in creating this. One of my stipulations is I want them to try to fill up the graph as much as possible. So when we're looking at this, we understand that tables, our first column is going to be our X value down here, or our independent value, which we'll talk about later. Our money is going to be our dependent, our Y value over here. So I'm going to put money over here. All right, again, blank spots here, we can fill them up with how we want to show our numbers. It's probably not the best way to say that, but how are we going to represent these hours? Again, I like to fill this up. Since we only have 4 hours, I don't really want to use each one of these tick marks as an hour. So I'm going to skip a line for each one of those. All right, so basically each one of those represents half of an hour. Looking at our money, this we do have to take a little bit of time on because look at this. Our smallest number is 1,500. Our biggest number is 3,000. So let's see if maybe we can go by 500s. And again, I'm going to skip a tick mark, which is fine. Notice that my values are not the same, but as long as everything is even and organized, it's okay to start wherever you want. Also notice that I'm only using quadrant 1 of the coordinate plane. A lot of times with story problems, we are only going to use that quadrant 1. Here's our origin right here with our 0, 0. Right? We have our, again, X values and our Y values. Let's go ahead and plot these. So at hour 1, we had $2,500. At hour 2, we had $1,500. At hour 3, we had 2,000. In hour 4, we had 3,000. So a good way to understand that we have the same type of information seen in 2 different ways. Those relations we can visually see in a graph or a table. All right, looking at number 2, they actually have a graph here that shows the attendance of the concert so far. So we're supposed to look at their graph and summarize that meaning. We're going to interpret what this means. Well, we're comparing time versus the people at the concert. Looks like it's steadily increasing. Then all of a sudden, so we had people steadily attending, and then it looks like no one came through the doors right here. We still have all of these people here, but no one came through the doors, and then at this time, we had a pretty good increase. All right, this is a pretty small amount of time right here. So how do we put that together as a meaning? We're going to say that there was a steady flow of people coming to the concert. And then I'm going to say, and then for a short time, no one came. So this could have been like maybe a members only type of thing where they came in, they shut the doors, had a little mini concert, and then this is when the regular attendees could have come. That could possibly be what this means. So we're going to say after that, there were quite a few people joining the concert. So graphs, in a nutshell, are a very good quick visual interpretation of what is happening. This would have been a little bit harder to see with numbers. This graph, we can just quickly look at that, have a nice little summary of what was happening at this concert. So again, a lot of review, but a lot of vocab that we have to have a solid understanding of in order to finish out the rest of this chapter. So go ahead and get out your notes and vocab for this section. Okay, objective of this section is to identify domain and range and interpret graphs. All of this vocab I'm not really going to go over because we did talk about this. We have our coordinate grid, our y-axis, and our x-axis. Each one of these is an ordered pair. So when we talked about our hour one and our $2,500, that was an ordered pair or a relation. And a graph is called a coordinate plane. We've talked about all of those. There's actually many different ways to represent information. We looked at a table in a graph. We didn't look at it as an ordered pair, but again, that hour one of $2,500, we could have written as an ordered pair because here's our X value and here's our Y value. You can also use it as a mapping. And sometimes the mapping, when we look at the next section, works really well. In a table, we talk about domain. Domain deals with all of the X values. So I'm going to put a D over the X because we understand that that's all of our domain. Our range deals with Y. Again, something that we have to have a solid understanding of for the next section. I always think X comes before Y in the dictionary. So domain deals with X, range deals with Y because D comes before R in the dictionary, if that helps out. Again, the X values of a relation are members of the domain. Y values are relations of members of the range. So if it says what is the domain of this relation up here, that's going to be the -2, the 1, and the 0. That's why tables sometimes are really nice because it sets up the domain for you. It sets up the range for you. All right, let's go ahead and look at example 1. It says that we're supposed to express this relation as a table, a graph, and a mapping. All right, first off, it says that we're supposed to put all of our X values here, our Y values here. So really what we're doing is we're just taking those ordered pairs and getting rid of the parentheses as well as the comma. So 2 is related to 5, -2 is in relation to the 3, 5 is in relation to the -2, and -1 is in relation to the -2. Now we have to look at that as a graph. So this is saying that we're going to go 2 over and 5 up. -2, so we're going to go 2 to the left and 3 up. Sometimes computers don't work very well. 5 to the right and 2 down. Again, 1, 2, 3, 4, 5. And then 1 to the left and 2 down. Just getting used to understanding how graphs work. Now looking at a mapping is a little bit different. What we're going to do is we're going to look at our table and set it up just like that. Here's our domain. So we have 2, -2, 5, and -1. And then here's our range. So I'm going to put this as our domain. Our range values are our Y, so 5, 3, -2, and there's another -2, so I'm not going to repeat that. Now I'm going to show the relation. The 2 is in relation to the 5. The -2 is in relation to the 3. The 5 is in relation to the -2, and so is the -1. So that's what a mapping looks like. Again, using that table to put it together. Now we're supposed to determine the domain and range of this relation. Well, again, maps and tables work out very well. So we're going to say that the domain, and I shouldn't use a parenthesis because this is actually a set, so we have to use that type of bracket, is a 2, -2, 5, and -1. Okay, our range, solution set 5, 3, and notice I'm just going to put -2 there because I'm not going to repeat that. And I'm going to close my solution or my set because that's what, and I'm terrible at making those brackets, but it's a set. This is the set of the domain. Okay, go ahead and look at those actually 4 different ways to represent a relation on guided practice 1. Okay, this is what it looks like. And to reiterate why we have different ways to represent these relations, graphs are a quick way. Maybe we can see that there's a pattern going on. The mapping is actually a quick way to see if we have elements paired with the same element. So we realize that we have 2 domains that are paired with the same range. Okay, looking at the domain and range, maybe we have to see the spread of what we have. Well, we have between 0 and -4. Same thing with range. So sounds maybe redundant to look at it in different ways, but sometimes we need to analyze information in different ways. Okay, I brought up the independent and the dependent values. So looking at this next section, it says in a relation, the value of the variable that determines the output is called the independent variable. The variable with the value that is dependent on the value of the independent variable is called the dependent variable. Domain contains the values of the independent variable. Range contains the values of the dependent. So very wordy, but what that means is that independent deals with X, deals with domain. Dependent deals with Y, deals with the range. Okay, think about our function machine. Independent is what goes into the machine. Dependent is what gets spit out. Okay, sometimes we have to identify what is the independent and what is the dependent. And a lot of times what I tell the students to do is complete this sentence. What depends on what? This is going to be your dependent then. This is going to be your independent. So you can fill in those blanks and that will tell you what relies on what. Might make more sense if we go ahead and look at A. It says that the dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. So it looks like we have the amount of money that we can spend on decorations depends on how many tickets they sell. So I'm going to, again, kind of fill in the blanks over here. So the amount of money for decorations depends on amount of tickets they sell. Okay, so completing a sentence, I can see that that's my independent value. Okay, I'm going to stick that we sold 300 tickets into my little function machine, and it's going to tell me the amount of money I have for my decorations. So independent is the amount of tickets, and dependent is the amount spent on decorations. Okay, sometimes looking at that little filling in the blank does help. So let's go ahead and try that on B. Generally, the average price of going to the movies has steadily increased over time. So what depends on what? Okay, well, it depends on what year we're looking at. So the price of a movie depends on the year that we're looking at. So price of movie depends on year. Okay, so price of movie is going to be our dependent. Year is going to be our independent. Okay, kind of handy using that. That really does help, especially when we're setting up a graph, because notice, remember our graph, we talked about money, or I'm sorry, we talked about hour being in our X value, and then money being in our Y value. So helps if we don't know what goes where on a graph or even in a table. All right, go ahead and try guided practice 2. Okay, these type of problems are really good summarization skills for those English people. Again, the air pressure inside the tire increases with the temperature. So rewording that, pressure depends on the temperature outside. So pressure is our dependent, temperature is our independent. Down here, the water level of the river depends on how much rain we have. So water level is our dependent, and the amount of rain is our independent. Alrighty, last one, looking at those graphs. And again, quickly getting a little summary of what that graph means. So a relation can be graphed without a scale on either axis. So again, notice that we don't know how much time this is. This could be minutes, seconds, hours, but we can get a quick interpretation of what's going on. So example 3, the graph represents the distance that Francesca has ridden on her bike. Describe what happens in the graph. So she maintained a steady pace. It looks like over time here she didn't go anywhere. So maybe she took a break and then she maintained a steady pace again. So we can go ahead and say that. Maintained a steady pace. She took a break. And it looks like maybe she slowed down just a little bit because it's a little bit narrower, but we're going to just say maintained a steady pace again. Okay, we don't really have to get very fancy there. One thing, some students really like to say, well, she went uphill and then she went flat and then she went uphill again. That's not what this is talking about. You have to visualize what we're talking about. As time goes on, she went farther, maybe away from home, the distance she was from home. Okay, so make sure that you understand the two things that we're looking at, time versus distance. Okay, go ahead and do that with guided practice 3. Okay, looking at driving to school, time versus distance. This first part shoots up pretty quickly. So that's what I said, that the person drove quickly right there. Then he had to slow down and stop a couple times. So he stopped here, he drove slow, he stopped here, so maybe a couple stop signs. And then he maintained a steady pace. I like saying that maintained a steady pace when I see a nice line, okay? Because, wow, I realize that I can't spell. It's kind of hard to write and talk at the same time. But that steady pace, we see lines. So again, that's driving to school. Change in income, I said that the income increases constantly. It's always going up. But I said not steadily, because noticing this right here, that's not a steady increase because it's not a straight line. Okay, so interpreting data, which is what we're going to look at in this section. So you are now ready to start the assignment for this section.